Hey guys, welcome back to the channel. I'm Muralidharan and this is on my channel Code with Murali. In this video, we are going to see Geeks for Geeks problem, guys, which is a last digit of a power b of a number. So this is the problem we are going to see. So basically this problem is, I will walk through the description of this problem one by one, and we are going to solve in the next step. So let's dive into the video, guys. So first I will explain the description. Okay, so actually the description is very simple. I will explain here. Given two integers a and b in the form of strings, so they're going to given the two integers, guys, which is the a and b, which is a is 3 and b is 10. So these two integers basically in a string format. So you need to see that it is in a string format, so we cannot proceed this in a string character. It is now as a in a integer character. Now it is as a string characteristics, so we need to mind it. Okay, and finally return the last digit of the a power b. So basically it is here, it is look like this. A power b is 3 power 10. Actually we don't know the 3 power 10. Okay, so basically guys, we're going to calculate the 3 power 10 of the value and finding the last digit, which is find the last digit is 9. Here you can see that it is a 9, which is the last digit of the value. So this is the answer of this problem. So we all know, actually we are going to do this problem in this simple way. So I will code this the simple way of how to do this, but it is not a working solution, but I will teach you. Here I will code the simple solution, which is results equal to a power b. Actually you all think in this way. So basically we just taking the a and doing the power of b and showing the result, and the result have the value which is 59049, and what they are asking is the finding the last digit of the number. So return the result modulus of 10. So basically modulus of 10 will return the last digit, basically the 9. Actually this way of solving this problem is not recommended, and wait, we will see compile and run this solution. Here you see, actually this kind of solution is giving the runtime error because of it takes much time than the program expects. Okay, so that's why it producing error. So this is not an optimal solution. This is actually this goes through a lot number of steps than it expects. So what we are going to do is we are going to do an optimal solution. So basically the optimal solution is we are going to use the cyclicity of the number. So I'm going to explain this using the Excalibur. Okay, so this is our problem. The problem is basically a is the 3 and b is the 10, we know. Okay, and a is the base and b is the exponent, we know. So 3 power 10, 3 is the base and 10 is the exponent. When we calculate this value, we get 59049, but we need to calculate this amount of value to get the last digit, which goes through a huge amount of calculation. It takes much space and time. So what we are going to is we are going to do this with the help of cyclicity. Actually some of you know what is the cyclicity, because cyclicity comes in the aptitude. Okay, basically the cyclicity is when here I'm going to do the cyclicity. I'm going to find the cyclicity of the 2, which is a 2 here. I'm going to take the 2 power 1. 2 power 1 is basically 2. Yeah. Next, 2 power 2 is 4. 2 power 3 is 8. 2 power 4 is 16. Here, don't see the 16, just see the last digit, which is 6. Okay. Here, we get 2, 4, 8 and 6. This is the last digits. Okay. And now you need to see 2 power 5, we get 32. Actually, we got the 32, but the last digit is 2. You see the 2. So basically the 2 is returning again. So this is the cyclicity. Actually the 2 is repeating itself again and again. Here see the 2 power 6, we get the 64. Here the 4 is returning again as the last digit. Here you see the 4 is returning again, and the 2 power 7 is 128, we know, and the last digit is 8. Here you see the 8 is returning again. Here as a 8, and 2 power 8 is 256. Here the 6 is returning again. So basically the last digit of the number repeating itself again and again in a certain frequency. So this is the cyclicity of the number. So this table will show you the which number has which amount of cyclicity. So here one cyclicity 1 1 1 1 1. So 1 power 1 is 1, 1 power 2 is 1, 1 power 3 is 1. Basically 1 power anything is 1. So this is the cyclicity length of the 1, and we know the cyclicity length, which is 2 8 6 2, and here this is the cyclicity which I am going to mention here. 2 4 4 8 6 2 and again 4 8 6 2. So the length of the cyclicity is 4, and again here in the 4 it is 6, which is 4 was a 16, and 4 into 4 into 4 which is 64, and again it is repeating itself 6 4 6 4, and again this is the cyclicity of the 4. So the cycle length is 2. So you all see which cycle length is bigger. Here the highest cycle length is, which is 4. You know, the highest cycle length is 4. You see, 1 is the least and 4 is the highest cycle length. So after the 4 it cannot returning. I mean, after the 4 it returning itself again and again from this fourth frequency. If it is 1, it is again repeating itself in the first frequency. When doing this, we can calculate the last digit. So my point is, using this cyclicity, we can calculate the last digit using this cycle length. So basically what I'm saying is, here this is the final solution of what we are going to do. Here 3 power 10 is 59049. We all know, but we need the last digit, which is this. This is the 9, which is the 9 we need. Okay, so 9 we need, which is the last digit. But instead of calculating this amount of calculation, we need to calculate this much amount of calculation. We just need to take the cyclicity of 10. 10 is basically 10 modulus of 4. Why we are taking 10 modulus of 4? Because we know the 4 is the largest cycle length. So again and again it repeating itself in the last 4. Okay, for every 4 it repeating itself again and again in the last digit. So instead of taking this amount of values 3 power 10, we can take it as a 2. Okay, just take the 2, which is 10 modulus of 4, which is we get the 2 as a remainder. So 3 power 2, which is 9. So we get the 9, which is the last digit of the value. So first we need to calculate the last digit of the base value and the last digit of the exponent, and calculating using that base and that exponent to get the last digit of the value. What I am trying to say is, here the base value, which is 3. Here the base value is 3 and the exponent is 10. Okay, so instead of calculating this amount of value 3 power 10, we get the 59049. 59049 is the value we get when calculating 3 power 10. But instead of calculating 3 power 10, which is 3 into 3 into 3 into 3 into 3 into until 3 power 10, we just calculate the last digits value, which is cyclicity of the value. What I am trying to say is cyclicity of the value, which is 3 power 10. Here you see 9713, 9713, which is every 4 times it repeating itself. So again another 2 is 7 is repeating in the 1, 2, and in the 10th position it returning the 7 again. So instead of calculating the 10, which we can calculate the 3 power 2. So we get the cyclicity of the value. So this is the simplest form I am explaining, guys. So let's dive into the coding, guys. Now I'm going to code this. Okay, first we need to understand the a and b are the strings, not the integer. So, and we are going to solve the edge cases of this value. So basically the edge cases is, if the a of 0, which is equal to 0, basically the a of 0, which is 0, then and length of the a, which is equals to 1. So basically what I'm saying is, here the first value, which is the base value, is 0, then 0 power any value which is 0, we're just returning the 0. Actually we have solved the edge cases of the a of 0, which is the first value, because it is a string. So if the value is 0, then we can say that anything, if the base value is 0, then anything 0 power exponent, anything which is 0. Yeah, we know 0 power 1 is 0, 0 power 2 is 0. So that's why we are returning the 0. And now we are going to check the exponent. So anything power 0 is 1. So b of 0 of which is 0, and the length of the b, which is equal to 1. If this is true, then we just return 1, because anything power 0, it is 1. So 3 power 0 is 1, 4 power 0 is 1. Okay, now we have solved the base cases, sorry, edge cases. Now let's move on to the actual code. Here what we are going to do is, now we know the base value is 3. So instead of taking this base value, we need the last digit of the base value. Okay, so last digit of the base value, which is finding the last digit, last. So we are going to take the base value of the the last digit of the a. So we need to convert the a to the integer value, and we are going to take it the remainder modulus to get the last value. So 10. Now guys, we get the last digit of the base value, and now we need the last digit of the exponent. So here mod is equal to, we are going to calculate if the integer of b, which is modulus of 4, is equal to 0, because we know we are just converting the b into the integer, and the b is basically 10. So we know the maximum cyclicity of a value is 4. So just calculating this 4, if it is returning the 0, now the value is 4. Okay, we know the value is 4. When taking modulus, when it gives the 4, now we know it is a 4. So just returning the same 4. If it is not 4, else it is not, then return the calculated value, which is int of b modulus of 4. Just returning the calculated value only. Okay, and now we have the last base value and the mod. Just calculating the result, which is equal to the last. So now just returning, by calculating this, we get the last value, the result. Now we need to return the last value of the calculated value. So the result modulus of 10. Yeah, now compile and run this and get the answer. Here you see, we get the output as 9. Okay, let's submit this. Yeah, it is accepted. Okay, it's passed actually. 1113 test cases has passed. Okay, so now we have completed and submitted the problem, guys. So you need to try it out by yourself. Okay, thank you for watching, and I will post this kind of videos for the next 30 days. So please subscribe to my channel so you don't miss my videos. So thank you for watching, guys. Thank you for your love and support, and bye.